In proof number 3, you're given that G is parallel to H, and you're given that 6 and 3 are supplementary. So if you see the word supplementary, you need to think that at one point we're going to be talking about something adding to 180 degrees. Again, they don't tell you things are supplementary unless you really need them. So when we're thinking about how to prove that angle 6 is congruent to angle 2, that might seem a bit weird at first, but if you're told that 6 and 3 are supplementary, you should also know that 2 and 3 are supplementary because they are consecutive interior. So that's another piece of information we'll probably use in this proof. So if 6 and 3 add to 180 and 2 and 3 add to 180, then it has to be true that 2 and 6 also add to 180. So in our proof, we know G is parallel to H, and that angle 6 and angle 3 are supplementary. And that is our given. If we start with this idea of supplementary, we know that the measure of angle 6 plus the measure of angle 3 equals 180. And that is definition of supplementary. So we successfully used this first piece of information. We said that they add to 180. So now let's think about this piece. If G and H are parallel, then that means that the relationships we talked about are true. The alternates, the consecutives, the corresponding. So I see 2 and 3 along line G and line H. I know that the measure of angle 1 plus, the measure of angle 2 plus the measure of angle 3 equals 180 because they are consecutive interior angles. So at this point you might get a little bit stuck. And what you have to think about is we need to show that because 6 and 3 are supplementary and 2 and 3 are supplementary, that 6 and 2 have to be the same because they're supplementary with the same angle. So what we're actually going to do is set these equal to each other. If this equals 180 and this equals 180, then we can set them equal to each other. And that is just substitution. And maybe if we look at the end, that would help you understand why we do this. If we want to say that 6 and 2 are congruent, we first need to show that 6 and 2 are equal. So this step is essential in letting us show that 6 and 2 are equal to each other. Because in the next step, we can get rid of the measure of angle 3 on both sides and say the measure of angle 6 equals the measure of angle 2 by the subtraction property, because we just subtracted the same thing from both sides. And now that we said 6 and 2 are the same, we can say that angle 6 is congruent to angle 2. And hopefully you remember when you go from equals to congruent, or vice versa, it is definition of congruent. If this is one that really got you stuck, probably in this middle somewhere, remember you can work backwards. Maybe you write step 6 first, and then write step 5 before that, and then somehow try to connect what you know and where you're trying to get. And if this is what stumps you, that's definitely the hard part, but the more you see this, hopefully the more natural it becomes, and you can remember some of the strategies you use to solve these proofs.